Okay, now we will start with the evolution, that is from IoT to IoE, how it all happens, that is the stages and the real world stories that relates with these stages. That is first we start with mission to mission. First, actually, the IoT, before IoT, it was a mission to mission communication. We all know that a computer to computer communication, such as a LAN protocol communication, and after that, it went through IoE, that is Internet of Everything communication, and after that, it all went through Industry 4.0, that is connecting everything with respect to missions through internet. So with all these steps, the journey starts with isolated machines to intelligent thinking and everything connected ecosystem in a real-time deployment. So first we start with OnStar. OnStar is a idea of machine-to-machine communication in an automobile network. And John Deere, it is all completely, the tractor is missionized with the internet to give suggestions of how clarity the tractor need to harvest. It need to plug the field so that the harvest may be good. And one of the Barcelona, that is a housing method of apartment connectivity through IoT, and Siemens, they want to introduce a networking protocol type for Industry 4.0. So what we will cover is a big picture of 4 stages of evolution, and stage 1, it starts with mission to mission communication, and stage 2, it starts with Internet of Things, and stage 3, it is Internet of Everything, and stage 4, it is Industry 4.0. It is and finally we go with a comparison. And in each things, a case study is also incorporated in it. First we start with OnStar, that is General Motors 1996 telematics, that is telematics breakthrough, that is how to get connected with the cars through this infotainment. And case study, that is John Deere precision agriculture at the scale, that is when you farm a land of more than an acre, you need to find it out in a way that the tractor plows it exclusively in the line it need to be. Then the smart Barcelona, that is a citywide network of networks, that is establishing a smart network in Barcelona to have good communication protocol types. And Siemens, which introduces zero defect smart factory through its network protocol. So we start with first picture of mission to mission, that is an isolated point between two missions. Mission to mission is actually like an isolated point between two missions, means if you are connecting a LAN within a system area, and again you are connecting a LAN within other system areas, so the LAN to LAN communications will happen, and it don't have any connectivity, actually, you say. I don't have any connectivity, there will be no connections established in that, and all the connectivities are through some form of either direct or indirect method of connections, and followed by Internet of Things, that is things that connect to internet through sensors and devices exchanging data over the IP networks. That is data over the IP networks is establishing network protocols that would make things better in the way of connecting it through IP services. And Internet of Everything, that is the things that are connected through people, process and data, that could cover a networked connection, becoming an intelligent and very relevant one. And cognitive coverage is it is something like an AI driven self-optimizing ecosystem across smart cities, industries and utilities, and these smartness comes over through AI driven protocol. The smartness comes through AI driven protocols. and the real world anchor for each stage is that is I have given with an example, that is OnStar, John Deere, Precision, and Smart City Barcelona, and Siemens, everything. So what is a machine to machine communication? That is a point to point communication between a machine and a central server. So no broader network would intelligently serve this. Actually, why it matters is actually you need to know a connectivity, that is a machine could not report their own status without a human. That really matters more, right? A human need to be there to know what actually things are. Then a commercial and a technical groundwork for cellular data modules need to be established. Then introduce remote diagnostics and predictive service calls before IoT was introduced, because only through a mid-range or a where or a mid communicator these things can be done in a good manner. Then then there is no common network protocol to share all these things. That is vendor market is available. There is no vendor market is available to do all those steps. Telemetric and remote monitoring and vending machine inventory and fleet tracking, all these things are that. And General Motors and others. So the first embedded M2M telematic system. So why this is classic M2M is a single purpose link, vehicle to call center only, and it is not just connected to a broader device network, and it is actually a closed proprietary system, and reactive automation, and foundation for what it all follows, that is mission to mission telematics. Actually, it is not something which we experience now. It is something cellular connectivity over the GPS and vehicle electronics. So there is no too much of connectivity between any of these steps. It is just a connectivity to onboard the vehicles in a good fine manner. So that is what stated over here. So built on a joint venture with Huggers Electronics and data processing, converging GPS, cellular, and vehicle electronics. So vehicle sensor reported crash severity, airbag deployment directly to a call center, a machine talking to a machine with a human only in loops for responses. That is, for all those steps, the machine to machine communication would establish, making it as a practical one to serve the feeders well, that is the users well. So it is that, like it is launched by General Motors in 1996 in Chicago Auto Show, live on 1997 models within 11 months of project kickoff. So the thing was very much appreciated actually. And after that, after a machine to machine communication, a direct internet connectivity must be there to set with the things apart, not from making things together. That is, failing sensors and connectivity cost more at those times. So we went with MQTT and COOP enabling interoperability. And the main thing idea is report status to the service and publishing data on an authorized service. All these steps found a good area. And why it mattered is enabled continuous granular monitoring at a scale of humans could never match manually, and opened entire industries as like smart agriculture, home automation, wearables, and logistics tracking. And data became a byproduct of every device, setting the stage. So all these states only one thing, that is how a tractor need to be improved and how the user uses a tractor, and all these things are added up in a day-to-day stage to monitor for the system. So John Deere actually precision agriculture, that is first they started with tractors, harvesters, and sprayers carry embedded IoT sensors tracking soil, yield, equipment, health, and location. Very basic thing a sensor need to do. And after that, here we have, that is the devices are deployed with IP endpoints and standardized data pipelines. sensing and action loop, and still domain specific things. That is, entire system need to be domain specific, very clear and precise, such that it does not carries any malfunctions. And internet of everything, that is, the devices stop working alone and they are all connected together in a network to do all those process, that is people, process, data and things, all those things. That is, IoT system gets interconnected via shared platforms and the human context and business processes. And in these areas, the most valued thing is this one, enabled cross domain optimization, like cities, utilities and enterprises. So all these on the whole give networks of network, that is, they are all connected together. So what these means with together, in the sense, people are directly connected to things, process is also directly connected to things, data is also directly connected to things. So things refers to all the physical things which are connected in a pipeline. So let me see this in the next video.